Hi all, welcome to my channel 100% concept clear methods in assignment problem. So we are discussing each and every methods in assignment problem one by one. So already we have completed Hungarian assignment method in constrained assignment method. In Hungarian assignment method, we also covered balanced problem and balanced problem, maximize type and minimize type. So if anybody want to check out these two methods, link is available in the description box. So today in this video we are going to discuss about traveling salesman problem. If anybody want to watch this same content in Tamil, link is available in the description box. Let's get start the video. See, traveling salesman problem. So from the topic itself we can understand that this type of assignment problem is related to the traveling of salesman. This is the important condition in the traveling salesman problem. A salesman starts from his city. So now salesman is going to travel to particular cities. For that he is going to start from his city. So whatever city he wants to go, he will visit those cities only once, not twice or thrice, only once. And finally he will return to the city where he started. So this is the important condition. That is, a salesman starts from his city, visits each city only once and return to his city. So this is the condition. As a result, the distance, cost and time will be minimum. So the main objective of traveling salesman problem is to minimize the distance or cost or time. So no maximum comes in traveling salesman problem. Then which creates complete cycle, which means this condition forms the complete cycle. That is, the salesman will start from his city and visits each city only once and return to his city where he started. So thus it creates the complete cycle. So this is the important condition that we have to satisfy in the traveling salesman problem. So let's see this with one example. See the question. A salesman has to visit 5 cities and return back to the city where he started. So a salesman is going to visit 5 cities and finally he is going to return back to the city where he started. This is what we have seen in the condition. So see, the distance between cities in kilometers are given in the matrix. So all the elements in the matrix represents the distance between cities in kilometers and suggest a route that minimize the total distance traveled. So here our objective is to minimize the total distance traveled. So hence it is a minimized type of sum. Now see the matrix. Here we have 5 cities, that is from cities, and here we have 5 cities, that is 2 cities. That is, the salesman is going to travel from this city to this city. So see, all these elements represents the distance between cities in kilometers. And see here, all the diagonal cells are infinity. Why they have given infinity in the diagonal cells? Because diagonal cells intersects the same city. See, from A to A city, from B to B city, from C to C city, and from D to D city, and from E to E city. It is meaningless to visit the same city. That is why they have given the infinity in the diagonal cell. So according to the condition, the salesman can visit from A city to B city, or from B city to C city, or from C city to D city, or from D city to E city, and finally he has to return to the A city again. But he cannot visit the same city. That's why they have given infinity in the cell which intersects the same city. Let's solve this sum with algorithm. Algorithm step 1. Solve the traveling salesman problem as assignment problem using Hungarian assignment method. So now we are going to solve the traveling salesman problem just like the assignment problem by using Hungarian assignment method. So see, the first step in traveling salesman problem is we have to solve the sum just like the assignment problem by using the Hungarian assignment method. So I have already uploaded the detailed explanation of Hungarian assignment problem with algorithm. So link is available in the description box. See, what is the first step in the Hungarian assignment problem? First step is we have to check whether the number of rows and number of columns are equal. In this sum, we have 5 rows and 5 columns. Therefore, it is a balanced problem. And step 2 in Hungarian assignment problem is row reduction. So in this sum, we are going to find the minimum distance traveled. So thus this is a minimized type of assignment problem. Therefore, we have selected the minimum value in the each row and then subtracted that least element with the balance element in the same row. So thus we got these answers. And then next step is column reduction. So for column reduction, we have selected the least element in the column wise and subtracted that least element with balance element in the same column. Thus we have found the answers for column reduction also. So next step after the column reduction is scanning zeros. So see, in scanning zeros, we have to draw the minimum number of horizontal and vertical lines to cover all the zeros. For that, first we have to take the first row and check whether it has 1 0. If it has 1 0, we can mark that 0, or if it has 2 or more 0, we should skip first row and move to second row. Likewise, we should do in all the rows. Once row is completed, we should do the same in column also. So by doing, I have marked this 5 zeros. So after covering all the zeros, then we have to check whether the number of lines and order of matrix are equal. In this sum, the number of lines and order of matrix both are 5. Therefore, the Hungarian assignment problem condition is satisfied. Now we can find the optimum solution. So see, the next step is assigning cities. See the next step, assigning cities. So from city to city. So see, these are the from cities and these are the two cities. See, from A, the salesman is moving to E. Therefore, from city A and he is moving to E city. Now see in E city. From E city, he is moving to A city. Now see, from E city, he is moving to A city. From A city, he is directly moving to A city. So see here, the salesman started from A and moved to E. From E, he has directly visited to A city. He has not visited to B, C, D city. Now see in the algorithm. So now we have solved the traveling salesman problem using the Hungarian assignment method. Now see the second step. Check for a complete cycle. That is the condition. So now we should check whether the Hungarian assignment problem solution satisfy the condition. So what is our condition? Our condition is a salesman should start from one city and visit each city only once and return to his city where he started. So see whether the Hungarian assignment method solution satisfy this condition. If yes, we should go to step 4. Let's see what is step 4. So see, step 4, the solution of assignment problem will be the optimum solution for traveling salesman problem also. Which means, if the solution that we obtained from the Hungarian assignment method, if that solution satisfies the traveling salesman condition, our traveling salesman problem comes to end in that stage itself, because the Hungarian assignment solution satisfies the traveling salesman condition. So then we can calculate the cost and time as usual we do. But in some cases, the Hungarian assignment solution does not satisfy the traveling salesman condition. So in that case, we should move to the step 3. See, if no, go to step 3. See the step 3. 3 methods are used. So in step 3, 3 methods are used. Those are, first method is adjusted by inspection. Second method is form a single circuit. Third method is iterative procedure, branch and bound method. So in this sum, we are going to use the adjusted by inspection method. So see, adjusted by inspection. So always in assignment, we will choose the 0 element and mark that 0 element. But what we have to do in adjusted by inspection is, we should consider the next least element non-zero element. So we should consider the next least element, that is the non-zero element. If least element occurs in more different places, so if we are considering 1 means, if that 1 occurs in more different places, consider all those different places one by one. So we should consider all those different places one by one. until it creates complete cycle. So until it creates complete cycle, we should consider all those least element one by one and check whether it satisfies the condition. So let's do this. So see, now we are going to perform the adjusted by inspection step. For that, we should select the next least element other than 0. So see here, what will be the next least element other than 0? Here we have 1. So that 1 will be the next least element other than 0. So mark this one. Now check whether we have any other one. See, also we have 1 here and here. So mark these also. So mark this one also and this one also. And check whether we have 1 in any other place. No, we have 1 in 3 places. So now we are going to consider all these 3 places one by one. So now first check this one. So see here, now we are going to mark this one instead of this 0. So see here, our first option is this one. So we are going to mark this one instead of this 0. So cancel the 0 and mark this one. So now we have marked this in row wise, so we should cancel in column wise. Now we can do the scanning process as usual. Now see in second row we have 2 0, so skip second row and move to third row. In third row we have 1 0, so mark that 0. So we mark this in row wise, so we can cancel in column wise. Now see in fourth row there are no zeros, so skip fourth row and move to fifth row. In fifth row we have 2 zeros, so skip fifth row. Now we have completed in row wise. Now check in column wise. See in first column we have 1 0, so mark that 0. So now we marked this in column wise, so we should cancel in row wise. Now see in second column all are cancelled, and in third column we have 1 0, so mark that 0. So now we marked this in column wise, so we should cancel in row wise. Now see this row is also cancelled. In this row we have no zeros. Now we have covered all the zeros. Now check how many cells we have marked. 1, 2, 3, 4. Now see, we have 5 cities, but we have only 4 marked element. So this option doesn't satisfy our condition. So now we are going to include the second option. Now see, in first option we got only 4 marked cells. So now we are going to include this second option also. Now see, now we are adding the second option also. First, mark the first option. This is our first option. So we are marking this one instead of this 0. So cancel this 0 and mark the first option. So when we mark in row wise, we should cancel in column wise. And this is our second option. So we are including this also in our solution. So mark this one. Now we marked in row wise, so cancel in column wise. Now we have marked our 2 options. Now we can do the scannings as usual. Now see in first row no zeros, so skip first row and move to second row. In second row we have 1 0, so mark that 0. So we mark this in row wise, so we should cancel in column wise. And in third row we have 1 0, so mark that 0. And we marked this in row wise, so we should cancel in column wise. And in fourth row we have no zeros, and in fifth row we have 1 0, so mark that 0. So we mark this in row wise, so we should cancel in column wise. Now check whether we have covered all the zeros. Yes, we have covered all the zeros. And now add how many cells we have marked. 1, 2, 3, 4, 5. We have 5 marked cells, and also we have 5 cities. So now check whether this marked element satisfies the travelling salesman condition. First we start from A city. So from A city the salesman is moving to B city. So from A he is moving to B. And now check in B. From B he is moving to E. B to E. Now check in E. From E he is moving to A. So here also condition is not satisfied because salesman started from A city and moved to B city. and then he moved directly to E city without visiting C and D city. So he has not visited C and D city. So our condition is not satisfied. Now second option is also not satisfied the condition. Now include the third option and check for the condition. See, second option also not satisfied the condition. So now we are going to include the third option also. Now see, now we are going to add the third option also in our solution. So see, this is the first option. So we are marking this one instead of this 0. So cancel that 0 and mark this one. Marked in row wise, we should cancel in column wise. And see, this is our second option and this is our third option. If we marked this option, we cannot mark this option because we cannot mark two elements in the same row. That's why already we have marked this one but we didn't get the answer. So now here we are going to mark this third option. So mark this. If we mark this, automatically this will become cancelled. Then we marked this in row wise, so cancel in column wise. Now we have marked the options, so now we can do the scanning as usual. See, in first row there are no zeros, so skip the first row. Now move to the second row. In second row we have 1 0, so mark that 0. So we marked this in row wise, so cancel in column wise. Now see, in third row. In third row also we have 1 0, so mark that 0. So we marked in row wise, so cancel in column wise. Now see, in fourth row we have no 0, so skip fourth row and see in fifth row. In fifth row we have 1 0, so mark that 0. So we marked this in row wise and cancel in column wise. Now check whether this solution satisfies the travelling salesman condition. Now see, salesman starts from A city. So from A city he is moving to B city. So from A he is moving to B. Now check in B. From B he is moving to C. So from B he is moving to C. Now check in C. From C he is moving to D. So from C he is moving to D. From D he is moving to E. So from D he is moving to E. Now check in E. From E he is moving to A. So from E he is moving to A. Now check for the condition. The condition is the salesman should start from the city and should visit all the city only once, and finally he should return back to the city where he started. Now check whether he have visited all the cities. See, we have A, B, C, D, E. We have 5 cities and see here A, B, C, D, E. Here salesman travelled all the cities. Also he have travelled all the cities only once, not twice or thrice. Also he returned back to the city where he started. He started from A city and he completed in A city. So now this satisfies the travelling salesman condition. And this is the optimum solution in the travelling salesman problem. Now see the last step, assigning cities. That is from city to city. These are the from cities and these are the to cities. See, from first A city. So from A city he is moving to B city. So from A to B. And from B city he is moving to C city. So B C. And from C city he is moving to D city. So C D. And from D city he is moving to E city. So D E. And from E city he is moving to A city. So E A. Now we have to find the distances between these cities from the question. So we should compare A and B in the question. See here, from A city to B city the distance is 13. And from B city to C city the distance is 14 km. And from C city to D city the distance is 15 km. And from D city to E city the distance is 16 km. And from E city to A city the distance is 12 km. Now we have found the distances between these cities from the question. So now we have to add these 13 plus 14 plus 15 plus 16 plus 12. The total of these is 70. Therefore, the minimum distance travelled in kilometers is 70. So the PDF for this sum is available in the description box. If you have any doubt, leave your doubt in the comment section. And if you found this video useful, like it and share with your friends and help them to understand concept easily. And for more related topics, subscribe to my channel. Thank you for watching.